Hello friends, welcome to my channel Math School. Today our topic is number system. Have you ever wondered whether numbers are invented or discovered? Well, it's a fascinating question that invites both perspectives. Consider this: if you had no prior knowledge of numbers but needed to count your cattle grazing in the fields, how would you keep track of them? One intuitive method might be to use physical objects like nuts or seed to represent each animal. For instance, when one cow returned, you pick up a nut. When two cows return, you gather two seeds, and so on. In this way, you are mapping each cow to a tangible item, effectively creating a one to one correspondence. This practice suggests that the concept of quantities exists independently of human invention. We discover the need to count and recognize quantities, which implies that numbers in essence are discovered. However, to communicate and record these quantities effectively, humans invented symbols. These symbols have taken various forms across cultures, such as Roman numerals, the Hindu Arabic numeral system. Interestingly, there is a popular anecdote not rooted in historical fact that the shapes of Hindu-Arabic numerals corresponds to the number of angles they contain. For example, 1 contain one angle, 2 contains two angles, 3 contains three angles, etc. You can see. While this makes us an engaging story, it's more of a mnemonic than a factual origin of the numeral shapes. Now, the evolution of number systems. The need to count gives rise to the natural numbers or counting numbers 1, 2, 3, and so on. This collection is denoted by capital N. But what if there is nothing to count? How do we represent nothing? This led to the introduction of zero. Can you comment who had invented the zero? When 0 is included with the natural numbers, we get the set of whole numbers denoted by capital W. In business, we often deal with profits and losses. Even temperatures may be high or low. To represent losses or temperature less than 0, we introduce negative numbers like -1, -2, and so on. Combining these with whole numbers gives us the set of integers denoted by capital Z. Now, consider the basic operations: addition, subtraction, multiplication, division. When you perform plus, minus, or multiply on integers, the results also an integer. For example, 2 plus 3 is equals to 5, 2 plus minus 2 is equals to 0, 2 minus 3 is minus 1, or 2 into minus 3 is minus 6. You can see all are integers. But what about division? Division is a different story. Dividing two integers doesn't always yield an integer. For instance, 10 divided by 5 2 is an integer. 5 divided by 10 is half, which is a fraction. Minus 6 divided by 18 is minus 1 by 3, which is a negative fraction. To accommodate such results, we defined rational numbers. Numbers that can be expressed as the ratio of two integers p by q, where q not equals to 0 and the set is denoted by capital Q. Like half, 5 by 78, minus 3 by 84, 16 by 9, 5 by 1, 3 by 2, etc. Comment now. Is 0 a rational number? Tell true or false. Every rational number is an integer. 2. Every integer is a rational number. How many rational numbers are there in between 0 and 1? Feel free to share your thoughts in the comment below. In our next video, we will delve deeper into this topic. Till then, stay tuned, like, share, and subscribe.